Okay, so the final problem that you're looking at here in this lesson is multiplying conjugates together. At first glance, do you see how these problems really don't look all that much different from these problems here, except for one little subtle change, right? And that's that vocab word conjugate. Where did we hear conjugates before? Think back to chapter 5. Chapter 5. Where's that memory lane page? Oh, there it is, completely blank again. Do you guys remember when you guys were solving and working with polynomial functions because of the quadratic formula? If I said, hey, 2 plus 3i was a solution, what also has to be a solution? Well, 2 minus 3i must also have been a solution. Same would be true with radicals. If we had known that, say, a negative square root of 7 is a solution, then a positive square root of 7 is a solution because of those zeros that are in front. So what we called these in the math biz is we called these conjugates. Okay? Here's what's so absolutely stinking awesome about multiplying conjugates together. Okay? And I will demonstrate this with something from chapter 5. Let's pick on these two guys. Okay? Let's see here. So, 2, clicky, 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 clicky. Now let's multiply these together. Okay? If we were to multiply two conjugates together, here's what's awesome about conjugates every single time when you first outer inner last them or do distributive property. First times first, the 2 times the 2 gives you the 4. The outer would give you negative, wouldn't that be 6i? And then the inner would give you positive 6i. Think something's going to happen there? You bet, yeah, something's going to happen there. And then last times last, the positive 3 times the negative 3 is going to give you a negative 9. And then the I times the I gave us I squared, right? Now, that I squared, we talked about that quite a bit. Wasn't that I squared always supposed to be equal to a negative 1, which allows us to substitute all those I squareds with a negative 1? So really, a couple things happen here. Number one, when you multiply conjugates together, see those like terms in the middle? The oi, as I called it with FOIL, those are always going to add up to 0, okay, because they're like terms. So you're always going to end up with 4, or not always 4, but you're always going to end up with an integer here. And then, because that I squared is the same as negative 1, it's really essentially doing 4 minus 9 times negative 1, which is really essentially the same as saying 4 plus 9, right? Which is saying 13. So here's something that's very interesting about multiplying conjugates together, which will come into play later when you're in your functions class in your next math course, is that when you multiply conjugates together, stuff that are two complex numbers, you can actually get a real answer out of it. Very useful in functions class, very, very, very useful in your trig class that you will see down the road. Okay? So all my job is as an Algebra 2 teacher is to introduce you to this concept and why it's so stinking awesome. Now here's the cool thing about conjugates. It works also with radicals as well. So do you see that 5 minus the square root of 7 and 5 plus the square root of 7, those are conjugates of each other? So if we were to multiply those together, I'll do a little bit of highlighting here. First times first, there's the 5 times the 5, which would give us the 25. Yes? Yes. Okay, now watch me do the last times the last here. I'll put that in green. A negative square root of 7 times a positive square root of 7, that would give us a negative square root of 7 squared, right? Just like an I times an I would give us an I squared. But wouldn't the square root of 7 squared be nothing more, just this part right here, I'm going to circle it. That's just 7, isn't it? Because it's really just the square root of 7, which would be a wacky decimal. But then you square that decimal, you're right back to 7 again. And so we're really subtracting 7 right there. And then what happens here when you do the outer and the inner, right? When you do 5 times a square root of 7 and then negative 7 times the square root of 5, I'll get rid of those. See how we, in the blue, you have those like terms there? Isn't that going to add up to, let me write it here in blue, wouldn't that be 0 square roots of 7? And 0 times anything would be equivalent to 0. So what I really have here is 25 minus 7, which simplifies to being simply put 18. 18, ladies and gentlemen, that's it. Can I show you a cool trick that you can do here to check your work if you're indeed working with conjugates? Is grab your graphing calculators. So we have 5 minus the square root of 7. Close that parenthesis and then close that parenthesis. And let's multiply that by 5 plus the square root of 7. Multiplying conjugates is super easy to check with your graphing calculator because your answer is always going to be an integer. Hey, 18. Great way to check your work. Okay? So we did do this correctly. Your turn. Okay? Let's do 6 minus the square root of 12 times 6 plus the square root of 12. Go ahead. Pause. Try it on your own. All right. Time to check the answer. First times first. 6 times 6, 36. Outer would be a 6 square roots of 12. Now I might be saying, well, Mr. Cook, could we simplify the square root of 12? Sure you could. But why? We know it's going to cancel out anyway or add up to 0 anyway when we do this middle part right here and have negative 6 square roots of 12. It really does not make much of a difference. Whether we call that square root of 12 or 2 square roots of 3. Won't really matter. And then don't we have last times last? So that would be negative the square root of 12 squared. Usually Mr. Cook notices that when I have a square root times the identical square root, I'm just going to write that. Okay? Saves me the effort of having to write this when ultimately I know that when I take the square root of 12 and then square it, I'm right back to here now, aren't I? Okay? So let's wipe out those like terms. Those square roots of 12s are going to add up to 0 square roots of 12. So now I have 36 minus 12, which would give us 24. Okay, I think we could check our answers here. We sure could. I'm lazy. Press second, enter. So it just types the same thing in there. I'm just going to arrow back. And now I'm just going to change that to a 6. And then 12. Uh-oh. Well, hit second and then delete to insert another parenthesis. And then 6 again. And then this one won't be so bad because it's at the very end. So now I'll just do 12 parenthesis, add another parenthesis. 24. Correct answer. We rock. We rock. We rock. Okay, so there is 6-3, ladies and gentlemen. 6-3, a couple of big points, big key points of emphasis. Okay, just to wrap this up, remember, you can only combine radicals with addition if they have the same number or the same quantity underneath the root and it is the same kind of root, right? So you see how we could have done this one here on the right but not on the left because it's a cube root and that is a square root. Okay. Secondly, do not give up so easily when the number are not the same underneath. You could possibly simplify the radical to get the same numbers underneath, and you actually could do it. Okay. And then don't forget your first, outer, inner, last, and that can help you multiply and multiply. Okay. Quiz 2, I believe I have you do a couple of these problems, so be prepared for that. Okay. Remember, if you run across any homework problems that you are struggling with, remember, hit me up on an email. Don't forget my email address. Here it is, mcook2. Don't forget the 2. Okay. At you know the rest, right? LakeviewSpartans.org. Okay. So just make sure it's mcook2. Okay. I have been sending you emails, so just simply reply to that one. Okay. Believe it or not, actually at this point I have received a few emails from a few of you, so keep them coming. Homework questions, I could easily send you a reply and it would be just on that homework problem. I could easily do that and do that in a couple minutes. Okay, not a problem. So please, please, please ask me questions. I am more than willing to help, even though I think contractually, union-wise, I don't think that I'm supposed to. But hey, I'm home. I'm not technically working. I'm just doing this for fun, right? I consider math fun. All right, maybe I'm the only one. All right, so happy homeworking, everybody, and we'll see you on the next lesson with 6-4.